Hello and welcome back to CS103 Machines, Languages and Computation, and welcome to week 6. So the main event of week 6, I'm afraid, is the class test. So this is on Friday the 30th of October, Friday of this week. As I've said, I'll release the test paper at 8 o'clock in the morning on my place, and I'd like you to upload your solution document by 8 o'clock. You've already got a lot of experience doing this now, so you know how to do it. It counts for 20% of your mark for this class, and there'll be one more class test before the winter break, which also counts for 25%. On the test, there's 5 questions, and I'd like you to do all of them. The subjects of the questions, the first one is on a direct proof. You've had plenty of experience doing these now, and I've put a revision example up for you. The second question is a proof by induction for you to do, and I've put a couple of revision examples up for you in this week's materials. The third question is going to be a question about the MIU system. Now, I haven't put any revision materials for this. I would like you to go back and have another look at the materials from that week, the MIU week, including, I do want you to read the article, the chapter from Gödel-Escher-Bach, as well as looking at those videos. So the question here is going to be on that material, and I would like you to engage with that stuff and be able to answer questions about it. Fourth question is going to be an algorithm. We've already done an algorithm. We did the palindrome algorithm as an example, and we're going to do another example this week, and I'll tell you about that in a minute. And then the fifth question, that's going to be on functions and mappings. That's this week's material. It's fairly straightforward, so I think you'll get it straight away. Okay, so that's the 5 questions. Each question is going to be marked out of 20. So they're all equally weighted, and that gives you a mark out of 100. So this week we're going to have a look at another algorithm exercise. We did palindromes last week. This week we're going to do a similar thing, but we're going to take in a list of integers. So you know what integers are, and the input is going to be a list of those integers. It could be of any length, remember. You need to determine whether or not the list that you've been handed is ordered. That means it's sorted into ascending order, or it's not ordered, not sorted into ascending order. In other words, if you're handed a list and it looks like a sorting algorithm has already put that list into ascending order, you need to return true. And if the list is not in order, then you need to return false. If you've got repeated elements in the list, say you've got the list 1, 2, 2, 2, 3, those are considered to be in order because a sorting algorithm would return that order to you. Now, I've given you some functions. I gave you some Python functions, including the Python function first. You might also want to use the function second of L, and that will return the second element of the list. So if you've got the list 1, 3, 5, that will return the element 3 because that's the second element. If the list doesn't have at least 2 elements, this will cause a runtime error. So if you call second of L on a list that's only got 1 element, for example, then a runtime error will occur. Okay, how are you going to tackle this? Well, you're going to tackle it just like you did before. First of all, create some test cases and make sure that you get full coverage, including all the edge cases that I talked about. Think about how you would solve those test cases. You can use the test cases to get your thinking going. Write down your algorithm. I think a flowchart is good. You can also use unambiguous English or pseudocode, but you've got to make sure that it can be understood by anyone, and flowcharts are really good for that. So I'd recommend that you have a go using a flowchart. Then pass that across to a friend, a family member or a flatmate, someone who doesn't do this class, and ask them to run the algorithm on one of your test cases. Pick a typical case. Can they do it? If they can't do it, or if they get the wrong answer, then revise your algorithm and try the whole exercise again. So I'd like you to have a go at that exercise. I'd like you to hand in your solution to that before the tutorial, and we'll take a look at it in the tutorial. So that's it for this, and I hope you enjoy the week.